In this video, I'm going to show you a couple more examples of how to construct a direction field or a slope field for differential equations. This first one here, we have dy dx is equal to negative x divided by y. I like to start at 0, 0 and work with my x-axis points and then my y-axis points. So let's start with 0, 0. When I plug in 0, 0 into x divided by y, I notice that it's going to be undefined because I have a 0 in the denominator. So to show this on my slope field, I'm going to draw a vertical line. Next, we have 1, 0, and we have 1 divided by 0, so again, it's going to be undefined. And you'll notice that's true of every point on the x-axis because we're always dividing by 0. So these are all undefined values or undefined slope. Let's go now to 0, 1. So here we can see that we're going to have 0 divided by 1, which has a slope of 0. So this time I'm going to draw a little horizontal line. And the next is 0, 2. I'm going to go 0 divided by 2. Again, we have another horizontal line. And every point on the y-axis will have a slope of 0. So I'm going to draw little horizontal lines. All right, not that interesting so far. So let's take a look at what happens at some other points. Let's go to 1, 1. So at 1, 1, when I plug that in, I see that I have negative 1 divided by 1, which has a slope of negative 1. So to draw this, I recommend that you take a ruler and actually plot it along 2 points. I'm going to pick these two here. And we would draw a line that looks something like this. So at 1, 1, I would draw a little blue line that follows this slope. That looks like this. So now I'm going to erase this gray line. You're going to use a ruler, so don't bother drawing a line. Okay. At 2, 2, we notice it's going to be negative 2 divided by 2, which is also negative 1. So again, we have another slope that's similar to this, or the same as this first one at 1, 1. And same as at 3, 3. At negative 1, we'll see that it's the same as well. So we're going to have negative 1 divided by negative 1, which will be negative 1. So again, we can connect these 2 points to draw our line, and we get a short little line right here on this grid point. And same with at negative 2, 2, and negative 3, 3. Okay. All right, so let's now go on to negative 1, positive 1. So when we have negative 1 divided by positive 1, and with a negative here, we get a positive 1 slope. So over here, I would draw a little gray, I could draw a long gray line like this to show my positive 1 slope. Draw a little line here to show that it has a positive 1. And then again, I'm going to erase my gray line. So now at negative 2, positive 2, I have negative 2 divided by positive 2. So again, that gives me a slope of 1, which is the same as the one I just drew here. So I'm going to draw a little line like this, and same as at negative 3, positive 3. When I get to 1, negative 1, when I plug that in, I'll have 1 divided by negative 1, so it's also going to be positive 1. So all along this diagonal here, these have a positive 1 slope. All right, starting to look quite interesting. So let's see what happens at 2, 1. So we're going to plug in 2 for x, 1 for y. So now we get negative 2. So to help you draw the point at this, let's connect this point here and this point down here. So I would use a ruler and you line them up. So that looks something like this. Oh, I want to use a gray line to show you it's different. And then I would draw a little slope at this point here, and I'll draw that in blue, and then erase my gray line. Okay. At 3, 1, I get negative 3 divided by 1, so this has a slope of negative 3. So if I drew my gray line here, this was a little bit trickier because I don't have a point at negative 3, so let's imagine there was a point here. And then when I connect, it would look something like this. Okay, so that's where you would place your ruler along that gray line. But then when you draw your little short line, it'll be something like that. Okay. All right. So now let's go to 1, 2. So at 1, 2, we get negative half. So this time we're going to, through this point here, we want a slope of -1/2. So we could connect something that looks like, or place a ruler at something along this line like this. Okay, so I would then draw a little short line like this here. Drew it a little bit low, so I drew it higher. Okay, and then the next one would be at 3 and then 2. So I would have -3/2. Now again, this one's a little bit tricky because we don't really have a point of 3. So we could say slope of, let's see, we could do 1, 2, 3. I have a point up here. And then we need, we have 3/2. So we have 1, 2. Oh, I went too far. So this would be actually over here, sorry. So this would be a slope of 3/2. So something that's maybe a little bit up here. Okay, so then my slope is going to be like that. Okay, so the next one is going to be 1 and 3. So here we have 1 divided by 3, so it's -1/3. So this time we're going to draw our line all the way maybe about up to here. So my slope is going to be quite shallow, like so. And then so on. So at 2 and 3, we have -2/3. So we would have a slope of -2, and then we would jump over to 3. So it's something a little bit like this. So what's happening is that you can see that this is getting steeper as we move over more and more to the right. And let's see what happens in this bottom quadrant down here. So we have 2 and -1 as our point. So we plug in 2 and -1. So we have a positive slope of 2. So if we wanted to draw a gray line to get a positive slope of 2, we would have something that looks like this. Okay, so when we draw our little line, we're going to draw something that looks like that. Okay, and then we go out to 3 and then -1. So then we have a positive slope of 3. So that we can draw with a point maybe down here that could represent our slope of 3/1. And we have a little point, a little line that goes like this. And so on. So let's do one more. So we'll go 1 and -2. So 1 and -2, we get a slope of +1/2. And that we can connect maybe these 3 points here. So this is where you would line up your ruler. So this, you can see, has a slope of +1/2, so 1/2. And then we're going to draw a little blue line here that represents our half. Okay, so you can keep doing this and continuing it this way until you have it all filled in. And so I've drawn all the points, or all the little markings here, and you get something that looks like this, which is actually very circular. So that means that the integral of dy dx equal to -x/y is actually going to give you concentric circles that look like this. All right, let's take a look at one more. We'll take a look at one that's a little bit easier actually here. So here, this one's an interesting one. So it says that the slope dy dx is always equal to 1. So this is quite straightforward actually. So no matter what our x and our y value are, the slope will always be 1. So this one's kind of easy because through all the grid points, we're going to draw a slope of 1. So you're going to just draw something that looks like this. And this should make sense because you actually know how to find the antiderivative of 1. So let me just finish this off really quickly. So all of these will have a slope of 1, such as so. So you know that when I take the integral, or the antiderivative of 1, I'm going to get y is equal to x. And then that would be plus c, which makes sense because x plus c is our lines. And they're all going to be lines with a slope of 1, as our slope is right here, plus c with all of these different constants or different y-intercepts.